Hello, everyone, and welcome to our SpudSmart webinar. My name is Dawn Hughes. I'm the editor at SpudSmart, and I have the pleasure of being your webinar host today. I'm really excited about today's webinar, so let's just jump right into it. We're talking today about how to save money on insect management. We all know pests are a reality in agriculture, but are there ways to optimize yield while saving dollars on pest management? Our guests today say yes, and they're going to tell us how they've done it. I'm really pleased to welcome Dr. Alan Schreiber and Dr. Tim Waters. Give us a wave, guys. I know you're together. Let me introduce the two of you quickly to our viewers, as quickly as I can with your extensive backgrounds. Alan is a farm boy raised on a cattle, corn, soybean, and alfalfa farm in the Midwest. He has a PhD in entomology with an emphasis in pesticide toxicology. Wow, words today. He worked first for the Office of Pesticide Programs at the US EPA, then was the Washington State Pesticide Specialist for Washington State University. Since 1998, he has operated a private agriculture research company with an emphasis in potato pest management. To say he's an expert on research trialing is an understatement. He's completed more than 250 research trials on potatoes and is the lead author on the control guidelines for mite and insect pests of potatoes in the Pacific Northwest. Tim is a professor, regional vegetable specialist, and the director of Washington State University Extension in Franklin and Benton counties. He is a faculty member in the entomology and horticultural departments of WSU and a well-known speaker on all things potato. Tim's passion is bridging the gap between scientific research and farmers' fields to bring solutions to real-world agricultural challenges. Obviously, Tim and Alan have a ton of experience and knowledge to share, but we brought them together here today because of a 3-year paired trial they conducted in commercial potato fields. The results were fascinating. I'm also hoping they have direct applicability to our viewers' production systems. Before we get started, let me just say a giant thank you to each of you for making time for us. The plan for the conversation today is that the two of you will give us an overview presentation for about 30 minutes, and then we'll open the floor to questions. For those who are watching live today, we'd love to hear from you. Please type your questions into the chat box at any time during the webinar, and we'll tackle as many as we can during the question and answer session after the presentation. Today's webinar is being recorded and will be available at spudsmart.com following this live event. After that long preamble, I'm really excited to just pass the floor to you, Tim and Alan. Thank you.
Thanks for the introduction, Don. So just give me 1 second here and I'll bring up the slides and then we'll get started. So this is Alan Schreiber, and I'm going to jump into this presentation. This project was funded by was a special project for the Washington State Potato Commission. And what we wanted to determine was whether we could reduce insecticide use, improve pest management, and reduce pesticide management costs without impacting yield and quality. We did not jump into this lightly or all of a sudden. Dr. Waters and I have spent many years working on improving insect pest management in potatoes on a wide array of pests, and we felt it was time for us to put together a lot of the research that each of us had done and see if we could move it from the small plots that we were doing research on and move it and apply it into a commercial situation. So this is a joint project between my company and Tim at Washington State University. It was funded by the Washington State Potato Commission. The three main potato processors, Lamb Weston, Stemplot, and McCain's, were hugely supportive of this project. We worked with more than 30 growers and all of their crop advisors. What we did was we paired fields. One field was the standard grower program. They did whatever they normally would do. We did not influence or attempt to influence their pest management decisions on one of the fields. In the other field, we did what we called enhanced integrated pest management, where we had action thresholds probably a little higher than what is normal. For example, often growers would treat for aphids at the first detection. We had a threshold of 5 aphids per plant, for example. We also, in the grower standard fields, they could use whatever insecticides they wanted. In the enhanced IPM fields, we worked with products that were softer, more selective, and preserved beneficial organisms. In effort to limit variables, we tried to have the fields next to each other. They were managed the same. They were the same varieties. And most of the fields were clear waters. We sampled the fields weekly. The data went back to the grower or the crop advisor. And as we reached thresholds, or we're approaching the action thresholds in the enhanced IPM programs, we worked with them on their selections for their insecticides. This required a lot of interaction between Tim and I, and between us and the growers or their crop advisors. And so there was a lot of discussion on this. We divided this into 3 regions. Above the yellow line was the North Columbia Basin. Between the 2 yellow lines is the Central Basin, and below the yellow line is the Southern Columbia Basin of Washington. And so we kept records separately for these 3 regions, which turned out to be a very important point. We started in 2019 with 11 pairs of fields and 2 scouts in just the central and the south region. In 2020, we expanded it to 18 pairs of field, and we did north, central, and south. And in 2021, we did 17 pairs of field. So this is commercial fields covering a lot of acres. We used beat sheets. We also looked at leaf samples, and we pulled back canopy and looked in the furrows. We sampled 16 times in the interior of the field, and then 4 samples at the edge of the fields in the 4 cardinal directions. One thing became immediately clear, that there were more insect pests in the southern basin, particularly aphid, ligas, thrips, and worms, and Colorado potato beetle from the southern half. So in the southern part of the central basin, the central part of the basin and the southern basin, Colorado potato beetle became the dominant insect pest, and was, even though insect pest fluctuated from year to year, Colorado potato beetle was always the most treated for insect pest. When we compared the enhanced IPM fields to the grower standard fields, we found that in the enhanced IPM fields, we ended up finding more Colorado potato beetle, ligas, loopers, and worms compared to the grower standard fields. That's not surprising for us, because we were allowing to a little bit higher action threshold. And so we told them to hold off, don't treat as quickly. And as a result, we did carry for a lot of pests a little bit higher level. In the enhanced IPM fields, there were 40% more thrips than in the grower standard fields, and a little bit more psyllids, but we didn't see much psyllid during this entire program. What is interesting is in the enhanced IPM fields, we had fewer aphids and fewer mites than in the grower standard fields, which is exactly what we would have expected when we're using the selective products that preserve the beneficials. And so we conserve the beneficial organisms, and they in turn took out the aphid and mites. And so this is exactly what we would expect if we were managing the system correctly. In year 2, aphids really surged up, particularly in the south region, very dramatically, pointing out that there is some year-to-year variation on the pest. Another pest, the 14 south fields had 650% more ligas than in the northern 22 fields collectively. And some of these fields had some stunningly high aphid numbers. Thrips numbers were much higher in the south, and they were lowest in the central. In general, there was a really big difference. The northern region had far less insect pests than the central and the south, except for thrips, for reasons we don't understand. The central region, which, by the way, where my research farm is, it's very unusual to see thrips, but they're very common to the south and they're common to the north part of the basin. And we also had far more worms per field in the south than we did the north and the central regions. The south was just kind of an insect pest jungle. So based on the first 2 years of data from this project, the insect pressure in the south was just substantially higher than the central and the north regions. There were more beetle eggs, large larvae, adults, wingless, winged aphids, more ligas, more thrips, more worms, more stink bugs than in the north and central regions. And for reasons we don't understand, in the east central basin, Colorado potato beetle doesn't exist, and we don't know why. Throughout the entire Columbia Basin, except for this one region, Colorado potato beetle is the most treated for pest, except in the east central basin, and there's simply no beetle there, and we don't know why. If you look at the difference between the exterior and the interior, on Colorado potato beetle, there were far more Colorado potato beetle on the edges of the field than in the interior field. And however, for aphid, ligas, and thrips, on average, there were more aphid in the interior and more ligas on the interior, and then more thrips on the exterior of the field. So for beetle and aphid, you can just sample from the edge of the field. I mean, for beetle and thrips, thank you, Tim. For beetles and thrips, you can sample from the edge of the field, but for aphid and ligas, you've got to go into the interior of the field, which is not always easy, but that's what you want to do if you want to make some accurate assessments for aphids and ligas. So when we looked at insecticide applications, virtually every field in our program had an at plant or lay-by for neonic insecticides. We do not have resistance in Washington or Oregon to any insecticides in the potato insect system. And so everyone uses neonics. So we don't count neonics in this. What we're talking about going forward is foliar insecticides. And also there's a lot of Vidate, which is an insecticide, but in this case, they were applied for nematodes and were not included in our analysis. In year one, the average number of insecticides per field was 3.5 foliar insecticides. The range was 0 to 8 applications. However, the enhanced IPM fields had an average of 2.5 insecticide applications, and the grower IPM fields had an average of 4.5 insecticide applications. In the central basin, where pest pressure was low, the enhanced IPM fields had only 2, whereas the grower IPM had 2.3. So where pest pressure was low, there wasn't much different. But in the southern basin, where the insect pressure was high, the enhanced IPM fields had 3.2 applications, while the grower IPM field had an average of 7. In year two, there was an average of 3 applications, down a half an application from the year before. Overall, the grower standard IPM fields had 60 insecticide applications. The enhanced IPM fields had 43 applications. There was a wide array of insecticides used because we have a lot of products registered and we have a lot of different pests. But there were 21 different pesticides used in 2020. There were 14 modes of action, which is very good for resistance management. The diversity of insecticides that's a great sign for industry. However, a lot of the use for pyrethroid insecticides, which does concern us because of the impact it has on beneficials. Overall, we had a 29% reduction in insecticide applications across the program. In the north, where we had the lowest pressure, there was 11% reduction. In the central region, where there's intermediate pest pressure, there was a 32% reduction. And in the south, where we had the highest pest pressure, there was a 50% reduction in insecticide use. And I'm going to shift this over to Dr. Waters.
All right. Thanks, Dr. Schreiber. So I'm going to talk about the economic considerations of this. And like Alan pointed out, it's really interesting. There's some trends between South and North Columbia Basin. And we've assumed that for a long time, and this project really pointed that out. And I'd also point out the obvious that where there's more pests, there's more opportunity for improvement, right? And we'll talk about that here in a little bit more detail. So, and again, I apologize. These are US dollars, but I'm sure you guys do the conversion rates all the time. But based on our average retail cost of insecticide and application, we didn't include surfactants and additives here, and we did not include the seed treatment or vidate. This is kind of for the first year. This is the cost of IPM for the different fields. So you'll see, like in the South Grower 1, in their IPM field, or the field that we help them manage, they spent $71 an acre on insecticide, while their grower standard was $146 an acre. So you can see that it varies from when you go to the North Basin with grower 2, you'll see that there's no difference because there was very little pest pressure in that field. So what we recommended was $32.50 an acre on average, and what they used was $32.50 an acre in their side of the field. So anyways, if you take this and look at the sum, basically we're seeing that we're spending a lot more in the grower standard field than in the IPM fields. But in the South Basin, where we have higher pest pressure, there's more opportunity for change or improvement. And that's what I just stated here. So year 2, similar results in year 2, based on average retail cost. And we know that every grower pays a different cost for their insecticides, kind of based on their size of their farm, that kind of thing. But in the North Basin, the average cost per acre was $75. The Central Basin this year was higher. There was fewer fields, and there was a major Colorado potato beetle outbreak. So that number is a little bit higher than we would see normally. And then in the South Columbia Basin, the cost was $69 per acre. If we look by tactic or management program, the grower standard management program was $104 an acre on average, where in our enhanced IPM fields, we were down to $63 an acre. And probably, we'll talk about that later. The average cost per acre by region, you can see broke out here. In the North Basin, again, grower standard was more expensive than the IPM, but not a huge difference there. The Central Basin, $145 for the grower standard program, where the enhanced IPM program was $106. And then in the South Basin, we see almost a double in cost for the grower standard program compared to what we were recommending. And one of the pushbacks we got from this, and Alan and I have been doing insecticide efficacy work for a lot of years. And when we test these new insecticides, one of the first pushbacks we get from growers is those products are more expensive, right? And so they definitely are more expensive. But again, we were hoping by reducing the number of applications that there would be a net savings. And we're seeing that in this data. Okay, so, and then the next question we get from growers is quality. And one thing I would have normally interrupted Alan, but we aren't in front of you guys, so I feel more awkward interrupting him and trying to be polite here. But one of the other pushbacks we got from growers was, what about our yield and quality? And it was really important that we paired with the processors on this, because the processors basically told us which growers they wanted us to work with. And then they ensured the growers that if there was a major quality issue from what we were recommending, that they would help keep those growers whole. So there wasn't as big of a risk for the grower as there might have been if we weren't pairing with the processor. So it's really key for us to work with the processors. So this is summary data from year 1, looking at paid tons per acre. And again, we have grower standard in the first set of lines there, and then the IPM program. And you can see tons per acre are virtually the same, percent usable is the same, percent bruise-free, culls, all down the line, specific gravity, all those things that our process growers get paid on are virtually, you can't tell the difference from the IPM field to the grower standard field. So again, this is really reassuring to Alan and I, because we were honestly a little bit nervous. We're researchers, and when we make a mistake on a small plot, it doesn't really impact anybody's livelihood, but we're looking at large circles, thousands of acres, and you guys know the risk involved with that. So we were pretty nervous that we could jeopardize growers' livelihood. So this is something we took really, really seriously. Again, so year 2, similar graphic or table, but colored a little bit different. Again, a little bit of difference in tons per acre here. Statistically, no difference when we analyze this. Usables are the same, bruise-free, specific gravity, percent culls, and processed culls all tracking uniform from one treatment to the other. And again, we did get some feedback that there, this could be a significant difference. But when talking to the processors who look at, hundreds of fields every year, this difference in yield was not significant to them in terms of averages. So kind of to try to summarize this, so the objective was to determine if applying these tactics, such as using action thresholds with higher thresholds, like Alan stated at the onset, not spraying insecticides preventatively or in a calendar fashion, the use of selective insecticides and intensive scouting could substitute for the use of insecticide applications. And based on the data that we have, it appears that in some cases, this is definitely possible. And like I stated a few minutes ago, the more insect pest pressure you have, the more opportunity there is for improvement. If you go to fields and you don't have insect pressure, growers are generally not applying insecticides when they don't need to. Okay, so more in summary, 4 paired fields had no foliar insecticides applied to either the IPM field or the grower standard field, indicating that when given the absence of a pest or pressure, growers don't apply insecticides, and there's no opportunity for reduction of insecticides.
Tim, I'm sorry to interrupt you, Tim. If you can just tilt your screen a bit, your head was a bit cut off. There we go. Perfect.
Okay.
That looks good. Sorry to interrupt you.
Yeah, Alan and I both have faces for radio anyway, so nobody needs to see our face. However, for most fields with heavy pest pressure, it's typical to reduce insecticide use by 2 to 3 applications. In the most extreme example, the grower standard field had 8 insecticide applications, while the enhanced IPM field had 3. So that's really a situation where there was a lot of pests were occurring in relatively low numbers, and by reducing increasing the interval between applications and using softer insecticides, we're really able to make a big difference for that grower. So these results suggest that providing growers with supplementing scouting support and additional pest management expertise can result in managing potato insect pests with reduced insecticides without the loss in yield or quality to our potatoes. Okay, so and again, just kind of reiterating some of the things that Alan and I pointed out through this presentation. So we see a difference in pest pressure from the north to south basin, and it's not always uniform. And like Alan said, there's variation from year to year, which our growers and consultants know that, and we know that. Using the enhanced IPM did not significantly change yield or quality. There's a strong interest from growers, crop production managers, and advisors for more and better pest management information. Our overwhelming obstacle in this project was these industry members are quite busy and often don't have enough time to deal with complicated pest management issues, but they were very receptive to our changes when we made the recommendations. So I would say that there was definitely a comfort level for the growers from Alan and I having scouts out in the field at least once a week. And I would mention that there were some times where we were pretty nervous about not making applications, but when we consulted with the growers, based on the data that we were giving them, they knew that we were walking these fields. They had a big confidence or high confidence level that these programs were going to work. And there were even a couple of instances where again, based on having this data, where I would have recommended and the grower said, you know what, based on having this information, I'm okay holding off on this. So a good learning process for the growers and Alan and I as well. And we did this for a third year. We didn't summarize this as well, but I just wanted to throw a few summary slides from the third year of this project. We didn't include that in the presentation, trying to preserve some time. But again, we looked at a bunch of fields. Alan told you the number there. We saw an 11% reduction. So an 11% reduction in insecticide use was initially really frustrating for Alan and I. We were frustrated because the first 2 years we felt like we made a big impact, and the third year we didn't feel like the impact was quite so good. When we thought about this, there were some reasons for that. Several paired fields had very difficult to control Colorado potato beetle infestations. So it really called for a higher number of applications, whether we were using the enhanced IPM or the grower standard. Potato psyllids across the Columbia Basin had high level of Liberbacter or zebra chip in them. So even in the enhanced IPM program situation, there was no tolerance for that. So we saw more applications there. And then the thing that we really came to terms with, which was kind of interesting to us, was that growers appeared to be shifting towards doing what we were recommending for the first 2 years. So initially we were frustrated by the lack of difference, but we really found that when we were contacting the growers and having those discussions, they were doing what we recommended on our field to their standard field as well. So again, kind of reassuring that the growers were doing what we were recommending. So again, reducing Dioxuric. So yeah, almost identical in year 3. So, we know that, making changes is difficult for growers. And we initiated another project that we haven't worked on in the last 2 years, but we were trying to manage insects in potatoes without neonicotinoids and pyrethroids. We feel like there is some work going on with neonicotinoids and how to manage insects and potatoes without those. But we feel like neonicotinoids and pyrethroids will be the things that regulatory pressure may exert onto growers, and they may not be able to use those products. So with that, I want to make sure I acknowledge people in this project. So with the Washington State Potato Commission, Matthew Blue was very helpful in helping us put these protocols together. The potato processor in Washington, and of course our growers. And then we had a lot of scouts that walked a lot of miles through potato fields. And I'm sure a lot of you are familiar with how difficult that is. Walking across a 120-acre circle, it's not an easy feat, but we had a lot of people that were willing to go out and do that for us for 4 days a week, and very appreciative to them. So with that, I think I'm going to stop sharing my slides, and then so that we can see see if there's questions and comments, and try to answer any questions. And just for the record, if you have easy questions, Alan will probably answer those, and I'll handle the more difficult ones. That's usually the way we work this.
Thank you so much, Tim and Alan. That was actually such a fascinating presentation. We do have, I'm going to open the floor to questions. We do have some questions coming. We have a bit of feedback on there. Okay, I'll just be sure to mute when after I finished asking the questions. So we have a question that asks, does this strategy work equally well across different growing conditions or potato varieties? How might your recommendations change for growers in the Canadian prairies or maritime regions?
Okay. So I think variety doesn't matter that much. Aphids, cholera, potato beetle, a lot of these pests are a problem regardless of the variety. There are some differences, like Umatillas seem to be more susceptible to ligas, so you can't tolerate as much ligas on Umatillas. So I'm going to say, in general, this will apply across varieties, but there are some varietal differences that you have to take into consideration. I'm not
add to that real quick. So the one caveat there would be virus transmission, like potato virus Y. So there's some varieties that are highly sensitive to necrotic strains of PBY. So there would be some differences there. And I think if you're growing a variety that to have significant issues with necrotic PBY strains, then you would want to manage your aphids more closely than if you have a variety that's more tolerant of PBY. But continue, Alan.
I'm not as familiar with some of the pest problems in the prairie and in the maritime areas, but my understanding is the pest pressure in some of those locations are not as high as in the Columbia Basin of Washington. So I think the lower the pest pressure you have, the less you probably are using less insecticides. So there may be less opportunities to reduce your insecticides.
Yeah, I think that's a good answer. And I think, like Alan, I don't know what the pest pressure looks like there. I'd be happy to share Alan with you guys. So if you guys want to take him for a couple of years, he could come up there and work with you. It'd really make my life a little easier down here. But no, I think that's a good, and like I said, the only thing, there are some varieties, like Alan said, that do tend to be more attractive to insects. And like I said, I would just watch out for those necrotic strains, and that would, help you determine how you want to manage aphids in those particular varieties.
Alan, we're going to start the bidding for your time pretty quick. So we have another question of, did you observe any long-term benefits beyond pesticide reductions, such as improved soil health or beneficial insect populations?
So that's a great question, and we collected a lot of data that we didn't present here. The soil health aspect is something that was not one of our targets, so we didn't look at. We couldn't answer it, but we have a lot of information on beneficials, and clearly, we saw significant differences between the grower standard programs and the enhanced IPM programs. There was always higher beneficial organisms, like a lot higher. And as a result, we saw fewer aphids and fewer mites because of that. But it was a very, very clear thing. If you're using a pyrethroid insecticides, you've just assassinated all your beneficial organisms in the field.
Yeah, and when we go to do aphicide trials, for example, in our fields, we apply a low rate of pyrethroid insecticides to kill our natural enemies so we can build our aphid numbers up. So, we're very familiar with that phenomenon. It's very common in the Columbia Basin. Actually, in Idaho, I got calls from Idaho and actually went over to Idaho to present this year because they had aphid outbreaks as a result of pyrethroid applications. I think those beneficials, they're sometimes hard to find, and people don't believe that the small number that they're finding is effective, but we've seen that over and over again. Aphids are kind of, just slow lumbering sacks of sugar, and everything wants to pick them off. And these beneficials are really good at picking off aphids when they're in low numbers. And same with spider mites. I think they really retain, keep the population in check pretty well. In terms of soil health, like Alan said, we don't have any data specifically on that. At WSU and at Oregon State University, there's some projects that more focusing on soil health. And we may have some more information to add to that in the next couple of years.
Fantastic. As you know, many farmers rely on conventional pest management. Question here is, how would you recommend they test this strategy on their own farm before fully committing?
Well, if you've got 2 fields, do one field with your normal plan and do another field that where maybe you will let the populations go a little, get a little higher, and then try some selective insecticides and try and preserve your beneficials and harness the benefit of the beneficials to control your pests.
One thing to remember when you're scouting with these new insecticides, with the older insecticides, you would make an application, you would have insect corpses in the field, right? Pretty quickly, within a few hours. With some of these reduced risk insecticides, the mode of action is different, right? So like you could be impairing the way that the pump on the insect mouth part works, or the insect mouth part may not be able to poke into the plant. So you need to remember with these reduced risk insecticides to know how they work. And still, you might go out and find aphids on the plant 4 or 5 days later. But understanding the mode of action is really important, because just the presence of those aphids doesn't mean that they're feeding and inflicting damage. So I think that's kind of a key thing to consider with these reduced risk insecticides.
I guess dovetailing on that question is another question of, do you think with the increasing regulations on certain pesticides that IPM will become a necessity rather than just an option?
Right now, we have, and again, in the United States, we have an embarrassment of riches in the number of insecticides that we have access to. I'm about ready to jump off a cliff on this one, but right now, the regulatory environment has changed in our country rather drastically since November, and we think there are not going to be changes in our access to insecticides. I think we're in pretty good shape. Where I have the concern is there are some market forces that may be a bigger cause for us to lose some insecticides. We can't get access to all the telone that we want, which is important for wireworm and certain other pest control. The neonics are under a lot of societal pressure, and some of the buyers are trying to move us away from some of those products. The other concern we have is development of resistance. And so regulatory constraints can be an issue. I think societal pressure and some resistance may be as big of a factor as regulatory constraints. And so we need to diversify the use of our insecticides. We need to preserve our beneficials, use integrated pest management, and that will help us keep some of these products that we might lose otherwise.
Yeah, and I think, this doesn't really add to that, but I just want to say something different. When you look at our growers and what they do, if you look at the number of insecticide applications that they make now, it is actually significantly lower than what they did 20 years ago. So I've got some records from one of our previous entomologists, and there's fields that had 17 and 18 insecticide applications to keep the insects under control using broad spectrum insecticides. So our growers have made changes. And like if you survey the same number of fields, like I think we did this in 3 years ago, I think the highest number of applications was like 7 or 8. So we've made big strides, and we can, but like Alan said, there's a lot of pressure, outside of just, regulation that may have an influence on these things. And we know, like neonicotinoids, for example, if you take those out of our system, it probably results in more insecticide application. It definitely it results in growers spending more money to control pests, which makes food more expensive for people. So it's really, and I think it's important that as an industry, we understand that, and that we're able to talk to people when we get the opportunity to educate them on why we use pesticides. Pesticides are a tool, and we know that growers aren't using them just to use them, right? They're using them to protect their crop. And we want to make sure that we articulate that well to people that are outside of the industry.
Thank you both. Another question is, what research or innovations do you see on the horizon for further improving IPM in potato production?
Well, there's that one, and there's plinazolone. I'll do. Okay, so we're both going to take a swing at this. There are some very interesting new products coming. One of them in particular is a product, doesn't have a brand name yet. You'll want to, but the common name for it is plinazolone. I'm not saying it would be a replacement for the neonics because it's weak on aphids, but this product plinazolone, I think, is going to have a lot of value to the industry. And then,
yeah, like there's RNAi products, RNA interference products, real specific products that can kill one type of insect generally, right? So there's one on the market right now, Leadprona, right?
Yeah, but
Calantha. And so it's really interesting. Alan and I have worked extensively like with that particular product. We know it's very effective, and I think that's just the start of many more to come. So I think the one thing it does is it makes the growers and consultants have to be better at IPM, right? So 25 years ago, you probably didn't have to be able to identify insects very well because most everything that you applied killed almost everything in the field. Now, if we're working with these more specific insecticides, it's really important that growers know the difference between an aphid and a small lygus bug, right? Or that they know what the beneficials look like. So I think that these new highly selective tools will be interesting for our growers to use. They're effective, and I think they're going to be good for preserving beneficials. So I think and like Alan said, there's still conventional insecticides that companies are developing that are going to be tools that we're going to use. But in general, they're going to be narrower spectrum, probably. They're going to be shorter residual. So it requires us to be better at IPM.
So when he mentioned Leadprona, which is the common name, and Calantha's brand name, that's a product that will take out Colorado potato beetle. It will kill Colorado potato beetle. It will not touch anything else. It has no mammalian toxicity, no ecotox. It is the most selective, safest thing that we've ever seen. This company is also working on the same thing for two-spotted spider mites, and they've got a pipeline of a number of other products. They're developing one for powdery mildew. They're doing one for gray mold or botrytis. They're doing one for varroa mite and honeybees. They're doing one for worms. And these are exceedingly soft touch products. The other trend that is coming, like it or not, is biopesticides and bioinsecticides. And that is, Tim and I both are testing products, and there's more and more of these biopesticides. And that is, and they're softer, they're selective, and they're going to require a higher level of management expertise in order to use those products. And it's like, well, give me a good old Timic or Monitor or something that will kill everything. But those kind of products are not going to be registered anymore. The products that come through are going to be softer, but it's more expensive to register conventional pesticides. And so it's a lot easier to register biopesticides. And so you're going to see the majority of the products coming onto the market are going to be biopesticides. It may not be the majority of the products you use, but the majority of the products that are coming onto the market as pesticides are biopesticides.
Forgot how to unmute there for a second. Okay, we are almost ready to wrap up. We have time for one more question, which is, what advice do you have for growers facing pressure from consumers and retailers to adopt more sustainable practices while maintaining profitability, which is, I guess, the crux of this?
So maybe repeat that. We had some weird sound interruption on our end. Can you repeat that?
Of course. What advice do you have for growers facing pressure from consumers and retailers to adopt more sustainable practices while maintaining profitability?
So I think that it takes a true integrated approach, right? So, growers can implement these. We know that these products work. And I think that this project proved that, to kind of reaffirm that with us and showed our growers that. I think that it takes more hands in the field, more scouting, a more deliberate tactic. It's more difficult for sure.
I think that if you wanted to, show evidence or show proof or give someone some evidence, I think, show them that you're scouting your fields and you're selecting products that preserve beneficials. You're maybe relaxed your action thresholds for some pests, maybe virus bearing aphids, or if you have Liberibacter psyllids, you don't let up on that. But maybe on second generation Colorado potato beetle, you can allow a little bit more before you treat. You selected products and you said, look, we're super IPM.
Yeah, and I think I think that we do more IPM than we admit. So growers sometimes say, well, I don't really do IPM, I just do this, right? But like crop rotation is a big thing in integrated pest management. And I'm assuming same way Ken, our growers rotate. They're on a 2 to 4 year rotation, right? That's IPM. Scouting your fields is IPM. So I think we need to be better at talking about what we're actually doing, because we're doing more IPM than I think we realize. So I think that that's maybe an important part. And now that's sort of what Alan was saying, I think. I just wanted to say it a little bit more articulately than he did.
Thank you. That does wrap things up for us today. I want to thank you both so much for making time to share your knowledge and research. This was a fascinating discussion. And thanks very much to our listeners for joining us. If you have additional questions about this webinar, or you'd like to share comments, we'd love to hear from you. And again, a recording of this webinar will be made available on smudsmart.com in about 48 hours. Thanks to you both.
All right. Thank you for the invitation.
Thanks.